All right, today's battery video is gonna be an update on packs that were 12S. We made a board to replace the proprietary BMS board that is on them, right? And today we got them. So we're gonna see if we can install it in there and make it work, right? So here are the batteries in question. Remember, there was two sizes. They were both 12S and they have this board in here, right? And we don't know, there's not enough of these ones to really dig in there, at least for me, really dig in there and try to figure this thing out and hack it and, you know, write the software to be able to access it, all that stuff. If we had truckloads of these, then I'd say we would do it. I would, you know, send one of these to people that I know that know about doing this stuff. So what I suggested was for us to make just a quick breakout board, something that we can, this is really easy to remove. All you have to do is desolder these points right here, and then the board comes out. It's got screws, right? And so all you have to do is unscrew it. And so we made it. I measured it. I measured the board and then I redrew it. And this is supposed to be a replacement. And this is just a simple breakout board. It just connects everything to this connector here, and then it connects it here. So it's just easy to have two connectors. One is for the BMS, the other one is just for power out. And here it is. Now let's see if it fits. It doesn't fit. That's the thing about these is that, well, you can very easily make a mistake. Okay, so the first mistake is here. This is not wide enough. Well, actually, you know what? This board right here doesn't go all the way to the edges, so I guess it's okay. Oh, I have this backwards? Oh, I have this backwards. Hold on. Maybe it does fit. Okay, so look, I just got the holes are just a little bit off. This is a guide pin. And then this guide pin doesn't want to go in there. That seems to be a little bit off. Let me see, can I put this guide pin? Yeah, see? Well, this guide pin works, but then I think the distance between these holes is not perfect. It's just a bit off. So I can go in the program right now and we could adjust this. In fact, let's do that right now. And then I'll show you because I noticed that a few of you guys downloaded the Gerber file for this. And so now you're gonna get some of these boards that don't fit perfectly, right? So all you have to do is just make these holes slightly bigger and it'll fit in there. Like the actual dimensions that we got wrong here they're just slightly off. Yeah, this one is a little bit off. If you move it a little bit that way, then these will fit. But then, yeah, and then we just make these two bigger. These three, we'll just drill them bigger and then it'll fit in there. Let me see, can I do that? Yeah, so basically to fix it, make this hole bigger and these three holes bigger, and then it'll lay in there. In fact, let's try that right now. Okay, so how did I get this wrong, man? I think I was using that caliper. You know what? I did use that caliper at home. That was just a bit off. So the problem is that I got this board just slightly smaller. Here we go. It's not much, but it's just a tiny bit. The thing is that it accentuates that problem, because here's the other mistake. So this whole side seems to be dead on. Like, you know, I measure from the edge, and then what I did is then I just measure from the edge of this thing, right? And instead of measuring from here all the way up here, like up, and put that dimension in there, I would have caught the fact that this is smaller. What I did is I just measured from the edge. And even that though, see, even that I got it slightly wrong, because look at that. That one's just a bit off. That one will work. This one is good, but yeah, it's just slight the mechanical's hard. Like you have to have a caliper that is not bad. You know, the problem is with my caliper is that it's one of those electronic ones and the battery runs out. Those things suck. The batteries are always running out, and I'm trying to use it without the battery, so I'm trying to read with the thing, but it doesn't have a mark, right? So maybe I'm reading like 1 millimeter or half a millimeter off, and then that's what I'm trying to. And so it took a while, or a few of these, for me to be able to realize, like, you know what, this caliper, I can't use that caliper like that. So I have another one that's manual here, and see, these are the problems. This wouldn't be this bad, I think, had I used a proper caliper. Hate those stupid ones with the batteries because it's like the stupid. And even that, see, it's a little bit off. That one, no, that one's dead. That one's right there. These are off a little bit this way and this dimension too. But see, it's crazy because it's only these two that are off this way. Okay, how to fix it? Let's drill these holes bigger and then see if we can put it in the thing and then make it work. Okay, here we go. Now we install the XT60 connector and then the little IDC connector, right? So now it's there. So now we just have to solder these. All right, so now that we have this assembled, the pads are also a bit off, but we'll fix that right on the file. What can you do with this now that it's all like this? Well, this connector right here, you can connect your BMS here, right? And then you can connect this into the negative, into the BMS and stuff. And you'll need one of these connectors, a 16-pin IDC connector. These are connectors that we use on all our other boards and stuff. So I made a little cable here. It's not perfect because there's one cell that is missing there from going from one to the other. So I have to put a negative from one to the other one. But it works. Basically, it allows you to then check the cells there. So there are 7 cells here. They're pretty balanced. And then there are the other 4 cells. And there should be 5 cells, but there's one cell that's between the negatives on this side and the positives on that side. So that's why there's no talk. All you have to do is put one cable, jump it from here, right? When you're making your special cable. But that's it. I'm gonna charge this and then I'm gonna discharge it just to show it working. And then we'll put the thermal camera in here to see how this board does. It's got a big giant trace in the middle here, and then all the other ones kind of zigzag, right? So let's check it out. Okay, so I'm going to charge that here using this. This is a top voltage on a 12S, right? Times 4.2, right? 12 times 4.2 is like 50.4. This thing only goes up to 50 volts. So that's okay. We'll just charge it, right? So here we go. We're gonna put 2, 3. This is what? 2 cells, right? So it's about 7. Let's do 5 amps. That's still below 1C. Or should we do 1C? Let's do 1C. Okay, so 1C charging. I know that's a bit fast, but just for the sake of time, right? Let's charge it. You don't want to charge your batteries that fast. That's like a 1-hour charge. But cars do it all the time, right? Now, of course, they do it with cooling systems and stuff, but this is just a little battery, and I'm going to monitor here. While And also we're gonna be monitoring the cells to make sure that not one of them goes crazy. While that happens, let's go to the software so that we can make all the changes to make this perfect, and then we'll update the file in the project, right? And so that way this will fit perfect when you get it and stuff and you do it. And look, I don't know, I know these are a small number of these. By the way, we just found a few more on our palette there, and so we're gonna list those today. So if you're watching this today when this video airs, there's a few more of these packs that are available on the link down in the description. But here's the thing, we might get more in the future, and if that's the case, then this is gonna become real useful, right, for you guys that buy these packs and you guys want to use them for your own DIY purposes, right? If not, then this is a good exercise on how to design a PCB breakout board like this for, you know, a battery that has a custom electronics, sort of like this, and then they're either too hard or not worth, you know, trying to hack, because that's a lot of work, right? For someone it might be easy, but for the general public, like regular people like me and you probably watching this video, this is a lot of work. And so, you know, you need specialized equipment, specialized knowledge, and so this is a lot easier to do. So let's go to the software and then fix all the little issues that this thing has. Okay, so issue number one is, see these numbers right here? We need to move those further apart because they're not as legible, right? This thing is smaller than the actual connector. So let's do that. Okay, the next thing is the width of the board. According to this, the original board is about 62 millimeters. And the board that we made is 61, so there's a difference of 1 millimeter, but that's enough to make a difference here. So let's bump up to 62 millimeters. Okay, so the next thing, you see how these screw holes, they match, but these pads don't? That one's just a little bit this way, this one's a little bit this way, this one's a little bit so I just need to grab all those pads and move them. And it seems to be getting worse towards the end over here. Yeah, it seems to, but if I just move them all, I'll measure this and then move them. Let's see here. How much do we need to move them? So about 6 millimeters according to this. 6 millimeters. I'm just gonna move everything 6 millimeters that way. Okay, so now this one right here, which is the first one, that needs to move up. And I guess what I really should be doing is measuring from here to there, but it's harder because then you have to do it at an angle like this. Well, what if you do that? Well, I guess you could do that. Or to the edge over here, and then that gives you center to center. Huh, let's do that, let's see. Let's see if that works out. So that is gonna be 55, 6, 7, exactly 57 millimeters from center to center, right? Center to center. Okay, next, what I need to do is, according to this one needs to be moved this way, right? This one has to be moved that way. This one has to be moved that way, because you could see there. Actually, you can't even see it on the camera, but, oh, here we go. When you put it there like that, you see them, right? And then also these pads have to be moved this way. Okay, so also the board can be longer to match the original one. I don't know why that ended up being shorter, but that's like 3 millimeters too short, so I'm gonna extend that. Also, the trace fuses here can be thicker, so I'm gonna thicken all those up just so that they can handle more current, right? Although they're just sense leads. But your BMS might want to balance at like 1 or 2 amps or something, so then that could carry that without the risk of them, because they're super thin here. So yeah, let's increase that. All right, so here's our test. I have connected this battery. It's at 50 volts, right? So it's fully charged. Connected to this 1,000 watt AC grid tie inverter, right? So here we go. That's 48.9, so 49 volts. It might pull about 30 amps. We'll see. That'll be enough to see. I think the cells can handle 30 amps. It's a 2, that'd be 15. Each one is 3. Whoa, maybe not. Maybe that's gonna be a lot. I think 30. I think it'll pull about 20 some amps. I think, right? Because I think at 50, if you do the math, I think we'll see how it does. But I think what happened is that it's gonna get hot. We're gonna push this battery right to its limits, and I think the cells are gonna get hot. I think everything else is gonna get hot. I don't think the board particularly is gonna be the one that gets the hottest here. But this is why you do these tests. Let's do it. So now we just plug this guy. Now it's gonna pull about 15 amps. Oh yeah, look at that. 16 amps. So 700 watts. Yeah, that's it. Okay, so look at the cells. I guess there is cell number 1, group number 1. It's a bit weak, so it's there we go. So it's pulling 16 amps. Let's pull more than that. Let me see if I can set it. Okay, so I just set it to 20. So we'll see what it does at 20. There we go. 400, 700. So it's 700 watts, 21 amps. There it is. Group number 1. So let's put the thermal camera. See. Oh my God, you see that? Those are the that's the exit point, the 2 exit points, and then the cells themselves are getting hot. right? The 2 exit points are gonna get hot because that's that tiny, I mean, that's kind of small nickel strip, right? So maybe that nickel strip is not gonna be up to the task of doing 20 amps. The cells themselves are getting hot. So it's 800 watts right now. That's what we're pulling off of this little battery. And this is the little battery, the one that it's only got 24 cells, right? 24 cells, so only 2 cells in parallel. So so each cell is giving about 10 point something amps. Yeah, 10 and a half amps basically. That's ooh, so what is the temperature there? That's the hottest one right there. 37? That right there has the shortest travel to the connector, right? That one over there on that side, that one has the longest travel. I mean, it's like this whole pad right here has to transmit the 20 amps across the thing, right? But that's a pretty big pad, trace, right? It's like almost the entire board on that one side is just copper pad, right? So, and as you can see here, everything else is getting hot but the board, right? It's the nickel strips, the cells are getting hot, but the board is doing fine. The board can handle probably 50 amps. Okay, so there are the cells. That's that band. That's the heater. And then the cells. So the cells are running hot. Look at that. Ooh, 50. Yeah, so the cells are getting hot. All right, there we go. So this board is more than capable of doing the max on this little battery, right? The battery can't push more than 20 amp continuous, so this board can. And according to our temperatures here, it'll do something around 40. So I'm gonna make the changes to make it beefier in the parts that are getting hot here. And then I'm gonna update that file, right? I'm gonna update that file on the project so that anyone that downloads it from here on is going to have all the changes, the mechanical changes and also the electrical changes. And then I'm going to order another sample, and then we'll do the large battery here, and then we can push that one, because look, I mean, we push 20, 40, 60, so we'll see if we can pull 60 amps off of this one through that board, right? But it will have to have those little changes. And we will see how hot it gets, right? Obviously 60, the cells are gonna get very hot. Yeah, just the same way that it got here. So I think the maximum that you can safely do on this pack right here, it's about 50 amps, right? So I've run 60 amps through boards before. It's just not that particular. So I'll be able to optimize that so that we can run 50 amps through this one right here. And I'll update it. And so, yeah, as soon as probably tomorrow or whatever, you'll be able to download the updated version that can handle 60 amps. 60 amps so that you can have these batteries, right? And if we get more of these, this is our battery going to be very useful. And if not, like I said, it's just a good exercise in designing a printed circuit board for a battery. And then, I'm showing that because I want to share my knowledge, the little stuff that I'm learning here, how to do this stuff. So if you find this useful, and if you want to start printing your own boards and designing your own boards, now you have an idea of what it is that it takes to do that, right? This is it takes a few tries. You order the one, and then you get all the mistakes out, then you fix some mistakes, and then you order a second one, and then even the second one you might be like, oh, I should have done this other thing this way. But after 2-3 tries or whatever, then you got the final one that fits perfect, and then it can handle all the power, and that it's got the right connectors and the right everything, right? So this is how it goes, right? And then you can share your own designs and stuff, and you can order them on our sponsor, our channel sponsor, right? I don't do a lot of sponsorships on this channel, only a few here and there, and PCB Way is one of those that it made sense because I'm designing so many boards, and so they're helping us by creating good service and you being able to share creating a place where you can share all these files and stuff, right? So, all right, thank you for watching this video. We'll see you guys on the next one. Bye.